Let's take a look at another stoichiometry problem that involves a gas. Suppose you have a strip of magnesium. You react it with HCl, and this reaction occurs. You produce hydrogen gas. So your hydrogen gas is collected in this tube over here. And you get magnesium chloride aqueous as your other product. So your hydrogen gas is collected over water. So this is water. And so what it did was displace the water from the tube. Okay? And the gas, since it's collected over water, has to be a mixture of hydrogen. It's not just going to be hydrogen, but it also has water vapor. Okay, so we say the gas is wet. Okay. Now let's say that the volume of this gas, which includes both hydrogen and water vapor, happens to be 2.50 liters. Okay. And the water level inside the tube is 10 centimeters above the water level outside the tube. So the difference here, so the height of this column, we say, is 10.0 centimeters. Okay? And the prevailing barometric pressure from the outside, the air outside, the barometric pressure is 755 torr. So 755 millimeters of mercury. Okay. Question: based on this information, how much HCl was consumed in the reaction, and what is the vapor? And you're given that the vapor pressure of water at room temperature, the temperature at which this experiment was done, was 23.8 torr. Okay, so if we want to know how much HCl was consumed in this reaction, you can figure it out from the moles of H2 that was produced, right? And so 1:2 ratio right here. 1 mole of H2 for every mole. 1 mole of H2 is used up for every 2 moles of HCl that's consumed. So it's a question of finding out moles of H2 based on the information provided here. Well, moles of H2 will just be what? Partial pressure of H2 times the volume over RT. Do we know the volume? We do. It's 2.5 liters. Do we know the temperature? Yes, we do. So it's really just a matter then of figuring out what the partial pressure of H2 is. Do we know the partial pressure of H2? Well, the partial pressure of H2 would have to be the total pressure of the gas, right, minus the vapor pressure of water. Why? Because your gas is wet. It's not just H2. So partial pressure of H2 plus partial pressure of water should add up to the pressure of the gas. So if you want just the partial pressure of H2, you have to subtract the vapor pressure of water from that of the gas. The vapor pressure of water is known. This is 23.8 torr. Okay? Do we know the pressure of the gas? Well, let's look at our setup. We know the barometric pressure. Okay, so here's your gas right here. So the pressure of the gas plus the pressure of the water column must be equal to the total pressure, the barometric pressure. Okay, so we can solve for the pressure of the gas by what? Subtracting the column pressure for the water from the barometric pressure. So that's barometric pressure minus the column pressure. That will give you the pressure of the gas. So that's how you need to solve this problem. And I'm going to leave it to you to figure it out based on the information given here. Okay? So that's the strategy you're going to have to use. Get the column pressure of the water, subtract it from the barometric pressure of the gas, barometric pressure to get the pressure of the gas, subtract the vapor pressure of water to get the partial pressure of H2, multiply by V over RT to get moles of H2, and then you get from moles of H2 to moles of HCl. Important thing to remember here, how do you get the column pressure of water? Okay, the column pressure, the water is 10 centimeters high, the height of the column. So just as a reminder, okay, so if you have 10 centimeters of water, that's 100 millimeters of water, right? So 10 centimeters of water. You can convert that to centimeters of mercury. 1 centimeter of mercury is equivalent to 13.6 centimeters of water. Mercury is 13.6 times more dense than water. So that converts it to centimeters of mercury, and then you can convert that to millimeters of mercury, which is a torr, so that you can subtract it from the barometric pressure, which is given in torr. Okay? And of course, don't forget eventually your partial pressure of H2 here. If you're using R of 0.08206, then your partial pressure has to be converted to atmospheres.